do the top hat to make us happy, and then you do the...
No, I do the top hat to make the others happy. Okay, whoa. Let's get started. I'll begin with a word of prayer. You guys are rowdy today.
Yes.
It's good. There's a seat in the back too if you want. You good there? Okay. I'll begin with a word of prayer. So, Heavenly Father, we thank you for this day. Again, I thank you for these students. Just pray that you'd guide our steps today, Lord. In your name I pray, Lord Jesus. Amen. So, this is the attendance sheet. Remember, I keep the official record of attendance on these sheets, although I do take top hat every day as to comply with various regulations. So if you, for some reason, miss the, code for top hat, do not fret, do not worry. If you don't sign on the sheet, then you should worry like a little bit, but like not a lot, because you could just sign it the next day, I suppose, if I forget to put these little X's in. But do make sure you check the box where you are counted there, if you would. Any questions about anything before I get back into the math?
Are we going to do the question from yesterday?
Yeah, we'll do that. Anybody able to do Dr. Sprano's problem? Anybody? Nobody? Anybody try? You looked up how to do it? Well, that's one way. So, let's begin with a slightly easier problem, all right? Let's try the integral of the sine of the square root of x dx. Now, this is a little bit dangerous. I'm not sure I can do this one. I think it's doable. I reserve the right to change this problem so it becomes calculable. I have a doctorate in math. That means I'm allowed to do that. So if you want to change problems on your test, you have to first go get a doctorate in math, and then you can do that. But you can bring someone else.
Yeah, can we bring in another?
We have all of these faculty meetings talking about success rates in courses, and about retention, about how to keep more, people in the seats here and things like that. And I've often said the way we could improve S rates, and it's very simple, I've thought of this, is we could just have the professors take the exams. I mean, if the professors take the exams, then everybody passes and it's all a success, right? So why not?
I think that's a good idea.
I'm okay. Genius, honestly.
It's like, when you run a marathon, the first thing you should do is do what? Like hail a cab, right?
Yeah.
So that's the way to be. Try implementing that in this.
Yeah, we'll be like guinea pigs.
Okay. How about no? Let's see here. So W. Let's let W equal the square root of x. The reason I'm using W here is because I'm about to use U and V for something else, I'm hoping. So if I let W equal the square root of x, first of all, I can't do anything to this, right? So the natural thing to try to do on this kind of problem is to try to change it, right? So we'll try a W substitution. And so like dW is dx over 2 square root of x, right? Which you really should look at as dx is equal to 2 root x dw, which is really 2w dw, which for some reason gives me joy to say. So this is actually, upon this change of variables, sine of w times 2w dw. At which point, we recognize this as a problem which we can conquer with integration by parts. Because if we've got x times the integral of something we already know how to integrate, we can use integration by parts to remove the x. We've seen that in like 3 examples now. Even the secant integral I started last class with, we saw that phenomena, although it led us to something not so helpful. Okay, so let's use integration by parts. Now it's in the variable w instead of the variable x, but the same principles remain. We're going to call this u. We're going to call this Oh, wait a minute. Other way around. If I do that, that's a bad thing. If I did this, this would be poor. Poor choice. Why would that be a poor choice? Let's talk about that for a second. Why do I not want to do that? Can you guys close the door in the back for me? It just, thanks. What's that? Yeah, integrating the 2w brings me to a w squared, which is not a step in the right direction, right? So what I should do is I should try to make the u the 2w, and I should make the dv the other part, right? So let's try this again. I'll use red. So I'm going to make this my d. I'm an idiot. Let's see here. Try again. U, and I'm going to make this piece and this piece here my dv, right? So I get uv minus the integral of v du, which in this problem is what? So let's see here. So this was for this step here. Then next I'm letting u equal to 2w. That makes du 2dw. And I've got dv is sine w dw, which makes my v equal to minus cosine of w, right? So this is the going from there to there. So what do I got? I've got minus 2w cosine w minus the integral of minus cosine w times 2dw, right? Now this is, like this minus and minus cancel to give me a plus, right? So let me just do that step. So I've got minus 2w plus twice the integral of cosine w dw. I mean, that step is not necessary. I'm just doing it so it's clean. Everybody sees what I'm doing, yeah? Then what? Well, we can integrate cosine, right? It's what? Sine? So what we have is minus 2w plus 2 sine of w plus a constant, right? Now whenever we make, yeah.
What happened to the cosine w in the first
Oh
one?
man. It's in the marker. Short answer to that is follow man. Let's see here. But I guess, let's see here, cosine of, 2w dw. So thank you. Very helpful. So plus 2, eventually I'll learn how to do calculus too. Let's see here, plus constant. This is why it's really important to teach to a class and not to yourself, you know? Okay, so then what? We don't want to leave our answer in terms of w, right? The answer should be in terms of x. So we have to undo the substitution at the start and go back, right? So what we have is minus 2 square root of x cosine of the square root of x plus 2 sine of the square root of x plus a constant. And there you have it. That's the answer, right? And I'm sure, I mean, not to beat a dead horse or anything, but I don't think any of us could have guessed this as just the function that you would pull out of your hat to differentiate to get back to the integrand, right? The fact that the derivative of the red boxed equation here, expression rather, gives you back the integrand, that's far from obvious, right? So this is a really neat, yep.
So you just have to use substitution for that, or because the way I thought you would do it is could you choose that sine square root of x as u and then dx as dv?
Sine squared of x?
Yes, sir.
But there is no sine squared in the original problem. Like the start of any integration by parts, we have to start by seeing this as u dv. So I can't just make u equal to sine squared.
No, sine square root of x.
Oh, u sine square root of x.
Yes,
oh,
sir. And then
I'm sorry.
And then use u substitution for that to find du.
So u sine square root of x,
And then dv would be
dv is dx. All right. And then what happens?
You would use u substitution to find the du.
Okay, let's see here. So du would be like cosine of the square root of x times dx over twice square root of x and v would be equal to x, right? So when I do uv minus integral of v to u for that, I would get, x sine root x minus the integral of v, which would be x, du, which would be cosine root x dx over 2 root x. So then I'd have to figure out how to do that, how to get that.
Yes, sir.
Is that what you did?
I mean, that's what I started doing, and then I saw you doing it.
Yeah.
But
It's not a bad, I mean, listen, if you don't have the idea to make the W substitution at the start, I think that's a reasonable course of action. And it's the only course of action, right? Because that's the only thing you can integrate there. Like, you're pretty much forced to make dv dx if you're directly going to do integration by parts, right? Because that's the only thing we can integrate in this expression, right?
Yes, sir. I'm still confused when you did W substitution. Did you do that just to kind of simplify it so you could work it out easier?
Yeah. So there are a class of problems where making a substitution before you do the integration by parts is needed.
I didn't know you could do that.
Oh yes, we can combine all these things. We're going to learn, hopefully you've already learned U substitution last semester. We're currently in the midst of, getting used to integration by parts. After that, there's something called, trigonometric substitution. After that, there's something called partial fractions. All of these things weave together eventually to make a coherent, whole of a sort of a toolkit for solving these problems, and you can use all of them in conjunction. It's kind of like when I was in community college. I used to dream of a physics problem that was the whole course. I wanted a problem that somehow involved conservation of momentum, energy, Newton's second, third law, everything we cover all in one problem, one grand, glorious, evil, complete problem for the course. And then my classmates told me that I should shut up. So.
Do you still dream about physics?
I teach physics, so sometimes, yeah. Let's see.
About your evil problem?
I mean, sometimes I make my evil problem a reality. Let's see here. So, example 2. So let's work Dr. Sperano's evil problem, because that actually requires something even perhaps more surprising. Something that you may or may not have been taught, unfortunately. Addition? Oh, man. All right. So, although, would somebody remind me what the problem was? Because I've lost the sheet of paper I wrote it on. X inverse tangent of x. Oh, square root of x. Square root of x dx. Okay, so the reason I did example 1 was to make what I'm about to do less mysterious. What am I going to start this problem with? A W substitution, yeah. So W equal to the square root of x. So again, we're going to get dx is 2w dw, just like we did in example 1, right? So what we're looking at here, but notice that if w is equal to x, square root of x, that makes w squared equal to x, yeah? So what I'm looking at here is a w inverse tangent of w. That's a w squared, rather. Sorry. I'll get it eventually. Dx was 2w dw, which is kind of terrifying. So I looked at this, and I was working out yesterday after class. I'm like, how is this reasonable? And then, all right, fine, have faith. Just try the integration by parts that you can do here, which is what? What? 2 what?
2w cubed.
Oh, sure, we can do that. So this is the integral of inverse tangent of w times 2w cubed dw. Sure, we can do that. At which point I'm going to say, okay, so pretty much that forces me to make this my u and make this my dv. Are we following Leate? Remember Leate? I think Leate is winning here, right? What did we make u equal to? The inverse function, right? So, yeah. Let's see if it works, though. Okay, so we're supposed to do uv minus the integral of v du. So let's see here. So what did I have? I had u equal to inverse tangent of w. So that makes du equal to dw over 1 plus w squared, because the derivative of inverse tangent is 1 over 1 plus x squared, if we have an argument of x. But here we got an argument of w. And my dv is 2w cubed dw. Integrate that, what you got? V equals to what? Integral of w cubed is what? W to the 4th over 4. But the 2 over 4 cancels, we get a half. 1/2 w to the power 4, like that. All right, so what are we up against here? We're up against 1/2 w to the power 4 inverse tangent of w, right? Minus what? Minus the integral v, which is in this case 1/2. I'll put a parentheses out here. W to the 4th dw over 1 plus w squared. I'll tell you what, I'll bring the w out outside here just to, I mean, you can write it either way, but there we go. You're like, well, that's not nice. How do you integrate w to the 4th over 1 plus w squared? Any ideas? What did you learn in algebra but have forgotten by now? A lot. I mean, it depends on where you took algebra, right? But there's something called long division that actually matters because you need it for a problem like this. And unfortunately, a generation of math educators has grown up who believes only in synthetic division. And synthetic division, in a nutshell, is garbage. So 1 plus w, because it doesn't allow you to solve this unless you use a twofold complex arithmetic with a meaningless algorithm that no one understands. So let's do long division instead. So I'm trying to divide 1 plus w squared into w to the 4th. Listen, disparaging remarks about math educators aside, if you have the power of the numerator larger than the power of the denominator, you can use long division to rewrite that fraction as the sum of a polynomial and what I call a proper rational function. Proper rational function is one where the denominator has a larger degree than the numerator, all right? So, and it's probably helpful for me to rewrite this as w squared plus 1 just for reasons of, well, I just know how I am. So how can I get a w to the 4th from w squared? I do what? Square, yeah, I need a w squared here. So if I multiply w squared times w squared plus 1, I get w to the 4th plus w squared, yeah? Then I subtract those, and they got minus w squared. How do I get a minus w squared from w squared plus 1? I subtract 1, right? And then that gives me minus w squared minus 1. I take the difference of those, I get myself a 1. At this point, the remainder has smaller degree than the divisor, which means we're done. You can do long division until what's your left over, your remainder. When your remainder has smaller degree than what you're dividing by, that's when you stop. So what does this mean? This means this little calculation we just did means that this fraction here we can rewrite in the following way. So we still got the 1/2 w to the 4th inverse tangent of w. And then, I'll leave the half out front if you guys don't mind. Integral of, apparently, w squared minus 1 plus 1 over 1 plus w squared. And that ain't so bad. That we can integrate, right? Because we can integrate polynomials all day long, and 1 over 1 plus w squared, well, that's just inverse tangent, yeah? So here we go. 1/2 w to the 4th inverse tangent of w. And I'll leave the half out front with a minus, big parentheses. 1/3 w cubed minus w plus inverse tangent of w. And then add a constant since we're done with the integration. Then what? What's the convert back to x, right? That's our finishing move here. let's see here. All right, so I'm gonna multiply the half and the third and all that stuff out and just kind of collect things. So I think I'll start with I guess I'll just leave it as it is in terms of the order of terms, but I'll multiply things through. How about that? So I've got 1/2. What's w to the 4th? It's x squared, right? So x squared inverse tangent of the square root of x, and then minus 1/6. W cubed is actually x to the 3/2 power. And then plus 1/2 square root of x. And then what? Minus 1/2 inverse tangent of the square root of x plus a constant. Now, at this point, students usually ask something like, is this going to be on the test? And the answer is yes, it could be. Right. That is the level of this class. This could happen on a test. Now, is every problem on the test going to be like this? Well, no. I'm not a monster. But it is a level of calculation I do expect students to get to. And I hope that working on the mission helps you towards that end. Yeah.
So again, like he was asking the other problem, like what if you just look at it and you're like, did not even cross your mind to the W? Like, is it still possible?
I don't know. I mean, are there other ways to do it? Possibly, but I don't know another way off the top of my head right now. Okay, so any other questions about this one? I mean, I stand by my decision not to do this yesterday. Yeah.
Would it be fine just pull 1/2 out of all the...
Oh, yeah, yeah. Of course, yeah, you could factor an x out. You probably, a half out. You probably could factor a, I don't know. You could group the inverse tangent terms together, or you could rewrite x to the 3/2 as x root x. There's all kinds of things we could do there. And I would count all of those problems. It's not like this is the unique correct way to write the answer, right? I understand equivalence of expressions. Yeah? So like there's not one right answer. But yeah.
What's the point of making w squared like just x?
I have to deal with it. Like what you make as your substitution has to substitute what's there. So like there's an x there, I have to change that to w, otherwise I'm not making a faithful substitution. Just like early, well, you were right. You were not, I thought you were actually not looking, I thought you were trying to put a sine squared there, and I was like, so but people do this kind of thing. It's like, not you, but.
I don't know a trick that well.
No, I mean like, people, like there's a lot of moving parts here, right? Like to make the integration by parts, we have to match the u and the dv, right? And they both have to match up with what we're starting with. Otherwise, it's not a faithful application of integration by parts. But there are two things you can adjust, right? The u and the dv. So if you kind of adjust one and forget that you also have to adjust the other, it's easy enough to make a mistake where you've got a perfectly reasonable dv in the sense you can integrate it, but what's left over is no longer your u that you claim it is. Like this happens. But, example 3. So here, let's jump back to a simpler time when we had to integrate something like, oh, I don't know, e to the x sine of 2x dx. So let's see here. If we believe in Liate, what should we do? I should make my u equal to what? Sine? Okay. So fine, I'll make this my u. I'll make this my dv. Let me just write it off to this. I'm an idiot. My bad. Let me just write it over here. U1 equal to, what did you guys just tell me a second ago, sine? And dv1 e to the x dx, yeah? So we've got u1 v1 minus integral of v1 du1 So that's like, well, v1 is e to the x again, right? That's nice. du1 is what? Yeah, 2 cosine 2x, very good, dx. And so what we got here is a e to the x sine 2x minus the integral of e to the x times 2 cosine of 2x dx. I regret not writing that lower and bigger. I'll fix my mistake now here. Let me take my penance. E to the x sine of 2x minus the integral of 2 cosine 2x e to the x dx. All right, there we go. I didn't do anything different there. I just wrote the same line again. I'm going to erase the uglier, smaller, offensive one. There we go. All right, so question, do I ever write something without a connection to a previous expression when there's a connected thought? I always have equality where there should be equality, right? Some of you guys are just kind of like pew, 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 pew. Just kind of shooting stuff here and there. There's no equality. There's no like, it's not, I didn't complain too much because, well, there wasn't much to I think on one of your quizzes I wrote floating. That's what I mean. I say floating. It would be something like, instead of writing the equals, I write this, then I write this, but none of the equals, none of the connecting statements, right? These connecting statements are part of the solution, right? You won't see me write something without them in here. Well, okay, anyway, I digress. So what, oh man, but, what do we do? You're like, you already wrote U1 and DV1s. I know what you're going to do. Clown. Let's see here. Right? What should I do? Do it again. Yeah. So this time we'll let U2 equal to, and you can, listen, you can do whatever you want with the 2. You can pull it out. Right? Let me pull the 2 out, actually. Pull it out here. I'll put some parentheses like that, yeah? So I'm going to make U2 cosine of 2x. And I'll make my dv2 e to the x dx. So my du2 is minus 2 sine 2x dx, and my v2 is e to the x again. All right. You'll forgive me if I take off the training wheels here for a second and just write down the integration by parts. So I'm supposed to do u2 v2, which is e to the x cosine 2x, right, minus the integral of v2 du2, which in this case is minus 2 sine 2x e to the x dx. And you know, the reason I put that parenthesis out front, this big pair of blue parentheses here, is because it's really easy to lose track of how many minuses you got here if you try to do it all in your head. Yeah. And I was talking to Dr. Sprano yesterday, and he's like, I told him, I was like, anytime I make a comment like that, it's like it's almost like a law that I'm going to make a stupid sign error right after it. He's like, yes. He's gotten so whenever he says something like that, he follows it up by, and beware, there will be a sign error coming up in the near future. But let's see here. Hopefully I don't. Minus 2 times this minus, and times that 2 gives me a net of minus 4 integral of e to the x sine of 2x dx. Do you guys agree? Disagree? Yeah?
And that's the original integral, right?
Oh, yes, and that's the original integral. So now what do we do?
Shift the original integral to
Right. I mean, what I do, I usually say, okay, I'm going to let the integral equal I. And what this equation then says is that I is equal to all of this. And this right here is what? I again, right? So you've got I is equal to this expression, right, minus 4i. So if we add 4i to both sides, we get 5i equal to, e to the x sine 2x minus 2 e to the x cosine 2x. Of course, you could factor out the e to the x there. We probably should, which then tells me that I, which is the thing we're looking for, is 1/5 e to the x times the sine of 2x minus 2 cosine 2x, and then add a constant. Notice that I've used a implication symbol here. Why? Because this is not a direct equality in here. So actually here is where I should even put the implication symbol. See, so like here this is literally equal to that. And the next step, I'm adding 4i to both sides to get to the next equation. So it's no longer part of the same equation. An implication, say, changing the equation to a new equation going forward. Yeah. And there you go, that's the integral. This is a integral which, what? This is one of those loopy ones, yeah? So it's an integral that loops. Yep.
So how do you determine it's 5i? Is that because of the ex sine 2x and then other?
Yeah, it's because I had I plus this expression minus 4i equals, I equals this expression minus 4i. So if I add 4i to both sides, I get 5i over here, I get no i over here, but I still have the expression, and then I divide by 5. And then, of course, what I've technically derived is a specific antiderivative for the indefinite integral in question. So to be fair and give you the most general antiderivative, I have to add the constant. Most of you have been taught to add the constant in your integration. There's a few of you who are kind of like, forgot to add the constant in the integration on the quiz. I don't take off a lot for that, but a little, like a decipoint. Should I go to millipoints instead? Yes. That way you more feel the gravity of your errors. Yes. I lost 10 whole millipoints on that. Dang it. 10 millipoints? Or would it be 100 millipoints? I don't know. I'm not used to my points yet. Let's see here. I don't know. This whole discussion seems pointless. Let's see here. I will say this. The year before Liberty made the 1,000-point syllabus a requirement for all courses, right? So when they took away the liberty to have an independent syllabus. The year before that, I had introduced a 10,000-point scale. I argue that it's 10 times as good as the current scale. So, although the students complained, they said it was very, very, what's the word? It was very stressful to take a test which was worth like 1,000 points. I was like, well, there were 100 points bonus on that test, though, in my defense. Let's see here. So, example 4.
Can you still do a 100-point bonus on?
See, if you guys would put that much effort into your homework, we'll have a success in here. Let's see here. So sine, let's try this one. Sine of the natural log of x dx. Let's see if we can do this one. So if I am a member of the Liate cult, what should I do? Oh, it's log, so log has to be. But see, you can't make u equal to log here. It's not multiplicative, W substitution. I don't think we need to do that. Let me cheat for a second here. Oh man, lost it. Hey, let's just try something. I think, I want to say, guys, what we do is make this equal to u and make this equal to dv, if I remember right. And let's try it, see what happens. So that gives us what, x, oh, excuse me. If u is sine of the log of x, then what? Du would be cosine of the log of x divided by x times dx, right? Because the chain rule says you have to multiply by the derivative of the log, but the derivative of the log is 1 over x, yeah? And my v, dv being dx, means that v is equal to x. So let's see here. Of course, uv minus the integral of v du, as usual. And so that gives me what? X sine of the log of x minus the integral of x cosine of the log of x over x dx. Well, that's kind of nice because that gives us what? X sine of the log of x minus the integral of cosine log x dx, which is, it's not, didn't solve it, right? But I think you might know what we should do next. Yeah, do it again, right? If we do it again, maybe we can get back where we started. Hopefully we don't, well, just because it looks like it's looping doesn't mean it loops to something nice, right? We saw with the secant problem that it can loop back to where it starts without the see, the minus 4 is wonderful. If it loops back to plus 1, you've just got integral equals integral, and it's like, oh, wonderful. But let's hope. So let's say u2 is cosine of the log of x. And that makes du2 minus sine of log x over x dx. And our dv2 will be dx, which means our v2 will be x. So basically, we're making the same integration by parts a second time. And, you guys are really stingy with parentheses. Like, what do you guys got against writing parentheses? They cost you nothing. But not writing them where there should be, logically, will cost you points. So some of you have already experienced this, yes? So if I took off points and I've got like markered in parentheses, what I mean is you can't just write minus and then a sum of things, where the minus is just magically understood to apply to the sum of things because that's what you're thinking. It's nice that that's what you're thinking, but you have to write the parentheses to actually apply the minus across a distributed sum. Like parentheses are your friend. Don't hate your friends. Let's see here. So, unless they're like Nazis, I guess. I don't know. We can all hate Nazis still, right? Is there another bad guy besides a Nazi? I will admit, I was thinking about getting a Kanye, like a West Trump 24 like sticker to put on my car about a week before that happened. Just because I thought it would be funny. Now I think it would be hilarious.
That would be so funny.
See, I don't know. Like, I'm on the fence, like, on whether or not he really believes. I think he really believes what he's saying.
I think he's just crazy.
Think he's just crazy?
Yeah.
Or is it just an exercise in you can't tell me what to do? Just because I'm a black man, just because.
On the fact that he just kind of wanted to get out of the deal with Nike, they wouldn't drop like a $40 million deal just because he wanted to drop it.
So it's all because he doesn't want to represent Nike anymore?
I mean, he hinted at that fact, but
couldn't he just like come out and like praise Reebok a lot or something, or Adidas? I mean, what is the competitor to Nike? I don't know.
That would probably bring us closer to Adidas.
Hmm. But I honestly, I'm on the fence a little bit. Like I feel like there's a chance that he's doing what he's doing just because he's been told he can't do it. If that makes sense. But anyway, I think you should, find a way to practice like independence outside of like supporting Hitler. Probably, yeah. There are other people that the mainstream media hates that you could praise that would be better. Let's see here. Where are we? Oh, yes, U2, V2, yes? So we've got X. How did Kanye get into all this? Cosine of... x cosine log x, and then minus integral of v2 du2, which there's another minus in there, but we've got x, and then minus, sorry, it's getting small here. My bad. I can't fix it. Well, I guess I could fix it, but close the big parentheses. Sorry about that. It's ugly. Let me clean it up on the next line. So what we get ourselves to is x sine of log x minus x cosine log x. These parentheses are not ones I would take off points for. And then notice how many minuses we got. 1, 2, 3, which gives us a net minus integral of sine of the natural log of x dx. So here's something I do sometimes just to try to save myself some writing. I'll give this thing a name like Pac-Man. All right? And so what this equation says is if I call this I, right? What is this? We've just shown that I is equal to Pac-Man minus I. About a third of you are having trouble with the algebra step I'm doing at the end of these looping problems, judging on the basis of previous Calculus 2 class. There's about a third of the students who just don't, for whatever reason, get this. Yeah? So all I'm doing is I'm saying we have I is equal to this, whatever it is, Pac-Man, minus what we're trying to find again, right? So solve for I. Add I to both sides. We get 2I equals to Pac-Man.
Pac-Man only has one eye.
But Pac-Man only has one eye. That's why we have to divide it by 2. Let's see here. So 1/2 Pac-Man. I can make nonsense arguments too. Let's see here. 1/2 x times sine of log x plus the cosine of log x. So the integral of sine of log x dx is in fact 1/2 x sine of the log of x. Oh, thank you. Thank you. Minus the cosine of the log of x plus a constant. There you go. I'm starting to get dizzy today. I don't know. I keep looping. Any questions? Yeah.
So if we see a problem like this in the homework, should we try it this way first before trying to do the W substitution at the beginning?
I mean, you want to try to do with the W substitution? We can try. Would it work?
I don't know. I didn't try it.
We can try.
I'm just wondering like what my approach should be like when I get through the homework.
Oh, try something. If it works, you try something. If it works, it works. And if it doesn't, try something else. This usually is restated in the form of, if at first you don't succeed, try again. Yes. Still good advice for calculus, yes?
On the homework, is there a way we can find if we get the answers right? Like, if
Oh yeah. You can easily check your answer by differentiating it and seeing if you get back to the integrand. That's bad advice for about half of you because you're very shaky on differentiation, which you need to work on. Because if you can't check your answers, that puts you in a perilous position. A more practical answer to your question is Wolfram alpha is a pretty decent way of checking answers.
Yes, sir. Thank you.
www.wolframalpha, and you can find the answer there. And if you pay a monthly subscription, I think it'll show you all the steps. I'm sure there is another website will show you all the steps. Sometimes they're good steps. Sometimes they're really, really stupid.
Yes. Sometimes.
So like, I don't know, like Dr. Sprano was grading the online calculus 1 or 2, and he showed me like this student work on one thing. If they sign a pledge, we're not using electronic blah, 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 right? And it took it was a problem about cosine, and like the initial step was, right, cosine is 1 over secant. It's like, no human ever does this. It was just so obviously computer done. So I would say just because the computer has a way to find the answer, it may not be the natural way. But that's not to discount like Wolfram alpha. I mean, it is helpful, right? In the same way it's helpful for you to hire a cab to get across New York City, but that's not going to help you run the New York City Marathon, which you will be doing in class here in about 3 weeks. Right. And also, you know, this class is a marathon, not a sprint, right? There's a lot in this class, and it goes on. So just take it one day at a time, like try to master one thing each day, you know? And before you know it, you will have another level of understanding of calculus that you didn't before. You will be part of a select crowd of people in the world, people who actually understand calculus. Those people are rare in the scope of all humanity, you know. But anyway, and if I was, you know, teaching you physics or something, I could show you how it's applied. But you know, you know, so there's a couple different schools of thought here. One school of thought is like, you should weave applications into the math lecture so the students will really appreciate it. I've a different school of thought. I believe that students should appreciate it because they're adults, and they should realize that if it's a requirement of your degree, it's for a reason. You know, and this is not a class that's here just to weed you out. It's not. You need calculus to understand engineering at the higher level. Like, this is the case. The theory of engineering, the theory of physics, it's all written in terms of calculus. So you'll never really understand those things which are basic unless you understand calculus. Now, you could argue, well, I don't really need trig substitution. Maybe. But understanding trig substitution will make you understand sine and cosine and everything else more deeply. Anyway, I digress. Example 5. Let's look at something. This is really different. So, actually, I'll let you guys vote. Do you want the one that's really different, or do you want one? Question: have I already done integral of inverse cosh in here?
Yes.
I like, did I do this one? I can't remember if I did. Oh, okay. So let's do one more of these, and then I'll move on to the weirder thing. Let's do inverse tangent then. I don't think I've done that one. How would you do this one? So I think we're just going to let this be our u, and this be our dv, yeah? So what we did yesterday was we derived the derivative of inverse hyperbolic tangent, among other things, yeah? So we did talk about inverse cosh yesterday, but we didn't, well, I know we didn't do the integral of inverse hyperbolic cosine yesterday. So what's du? It would be dx over what? What was the derivative of inverse hyperbolic tangent? Remember we argued. Nope. 1 minus x squared, yeah. I think the one you're thinking of is inverse hyperbolic sine. Okay, so, that was supposed to be, oh yeah, that's du. All right, great. So we have uv minus integral v du. What happens? We get x inverse hyperbolic tangent of x minus the integral of x dx over 1 minus x squared, yeah? And now what do we do? A u substitution, right? I'll make it a w. W equal to what? One minus, I've got to vote for 1 minus x squared. I've got to vote for x squared. All right, votes for 1 minus x squared. Votes for x squared. All right, now. As you know, math is done by consensus, so I'm honor bound to do w because 1 minus x squared. So dw is minus 2x dx, which means I've got x inverse hyperbolic tangent of x plus 1/2 integral of dw over w. So I canceled the minuses in the substitution, and my thinking there is just to solve for minus x dx equals to 1/2 dw. So then what? Well, that's natural log of the absolute value of w, and we're done. Well, almost, because we need to do what? Right, so that is x inverse hyperbolic tangent of x plus the natural log of the square root of 1 minus x squared plus a constant.
Why is there a square root?
Indeed. What?
I'm sorry.
No, you're fine. What are the properties? No, this is why I did that. And so we can have this conversation. What are the properties of the logarithm? Natural log of AB, natural log of A plus natural log of B, right? The other important one is natural log of A over B is log A minus log B. And what's the other one? P times log A is equal to log of A to the P, right? These are the properties of the logarithm we often use for algebraic simplification and so forth. So one option I have is if I've got a half out front, I can rewrite it as the log of the square root of the expression. Now, you might say, where did the absolute value go? And so that's a little bit more subtle. Like, at first glance, really, I should probably leave the absolute value in. I'm arguing that you could delete them. Why? It's kind of stupid, but why do you not really need the absolute value there? We're not dealing with complex numbers right now. What?
Square makes plus or minus.
No, I would just say, how about the context of the problem? So for the context of the problem is we're taking the inverse hyperbolic tangent, right? What's the domain of inverse hyperbolic tangent? The domain of inverse hyperbolic tangent of x is equal to the range of hyperbolic tangent, right? Remember last time we graphed that, and we saw that that was minus 1 to 1, right? And so if we're from minus 1 to 1, 1 minus x squared, what does it look like? How do you understand the sign of 1 minus x squared? Personally, what I do is I think about a graph. 1 minus x squared is this guy. It's got a y-intercept, x-intercept of minus 1 and 1, right? So if you're between minus 1 and 1, you're up in here, right, where it's positive, which means that 1 minus x squared is automatically positive, which means that this absolute value here is optional. So there you go. That's the integral of inverse hyperbolic tangent. Any questions about this one? Yeah.
I know you went over hyperbolic all day in class yesterday.
Uh-huh.
But it's still confusing to me, like how inverse of the hyperbolic tangent is like so similar, but like it's still different than like the inverse of tangent. It's like a nice exploring stuff.
What? So yeah, I mean, there's a natural question to ask there, which is like, what is the, what more can you say about inverse hyperbolic functions? How are they different from the inverse trig functions and yet so much the same? And that's a question you can continue to ask, and we'll continue to give more and more nuanced answers to that as you take more math classes, actually. I think that complex analysis is where a lot of that becomes really exposed. So Math 331 here. In some sense, the inverse hyperbolic functions are really just another notation for particular natural logs of algebraic functions. Let me show you what I mean. So let's take a short break here from the integration by parts, and we'll show you some algebra, which you probably haven't seen, and that's fine. Like if I'm teaching a pre-calculus class, I'll make this like a challenge problem, right? Or this might be like a bonus question on a test or something. This is kind of hard, what I'm about to do. So if we have, for example, y equals inverse cosine, hyperbolic cosine of x, right? Like that. then that means that x is equal to cosh of y. Right? But cosh of y is 1/2 e to the y plus e to the minus y. Yeah? So multiply by 2 and multiply by e to the y. And that gives us what? 2x e to the y equals e to the 2y plus 1. See, because the 2's cancel with the half, e to the y times e to the y is e to the 2y, and e to the y times e to the minus y is just e to the 0, which is 1. All right, so what? So then let's repackage this a bit. What we're really looking at here is e to the 2y minus 2x e to the y plus 1 equals to 0. What is this? Maybe I shouldn't have done that maybe I should have left this as e to the y squared. Because if I'd done that, you might understand that you can complete the square here. You can complete the square on e to the y. E to the y minus x quantity squared minus x squared plus 1 equals to 0. And the reason I'm completing the square is because I want to isolate e to the y. Okay, so this gives me e to the y minus x quantity squared is equal to x squared minus 1. What's the domain of inverse hyperbolic cosine, by the way? One to infinity, because it's the range of cosh. The range of cosh is 1 to infinity. The range of cosh is the domain of the inverse cosh. Always remember, functions, inverse functions have mirrored ranges and domains. So then I just take the square root of both sides, plus or minus, yeah? E to the y minus x is equal to plus or minus the square root of x squared minus 1, which then gives me e to the y is equal to x plus or minus the square root of x squared minus 1. But if this is e to the y, it has to be positive, right? So think about the plus or the minus. Since x squared minus 1 is, I'm trying to think here. I can't remember if I choose plus or minus here now. Do you guys have a reason for me?
The domain.
Domain.
The root of x squared minus 1 will always be less than x.
Does it have something to do with taking the natural log?
Less than x. But if I add it, it's still positive. That doesn't help me. What's that?
Flip a coin.
Flip a coin? All right, well, hey, let's just leave it for a second. I can't see it at the moment. If I take the log of both sides, I get what? Y is equal to the natural log of x plus or minus the square root of x squared minus 1. Right? And that's allegedly equal to inverse hyperbolic cosine of x. Inverse hyperbolic cosine of x, I know some things for. Like, for example, inverse hyperbolic cosine, well, I know that cosh of 0 is equal to 1, so that means cosh inverse of 1 is equal to 0. Right? So I can use that probably. If I plug in 1 here, I have to choose the minus then, right? Because in order to get this to work out, oh, wait a minute. Well, that's no help either.
That's right, because the natural log.
I know, but but this becomes 0. It's